Hi guys. Continuing on from yesterday's stuff. Yesterday we were talking about some of the basics of ecology, um, like the levels of organization in any particular ecosystem. Let me get my mouse back on this. Yeah, there we go. We talked about individual versus population versus ecosystem, all that kind of stuff. We talked about the two different types of factors in any environment: the biotic, which are all the living things in the environment, and the abiotic, those are the non living things. So the biotic things would be like two different species and how they interact with one another in uh, an ecosystem and environment. And the abiotic would be like how available is water in this particular section? Is there enough nutrients? Things like salt in certain salt deficient areas. So all of those things lead into an entire ecosystem uh, where you've got living things interacting with one another and the non-living environment. So today we're going to be moving on to a new section. We're going to be talking about energy flow in a system, mainly like what does something eat or does it even need to eat. Um, but let's go ahead and get started. So we're going through slides 8 through 19 today. Shouldn't take us too long. And once again, you guys are, this is just linked on Canvas if you want to go find it and look at it yourself. So you don't actually have to watch these, but if you want a little bit better understanding, you can come on here and watch, and that's just fine. So we're starting in 3.2. This is going over energy producers and consumers. You can only be one of two. You can either produce the energy in an ecosystem or you can consume that energy. And at the base of any ecosystem, we've got the primary producers. So for most of life on Earth, the sunlight is the main energy source. So anything on the surface, anything green, anything that's a plant, most of Earth's energy comes from sunlight. There's obviously some species that have used like geothermal energy or stuff like that, but for the most part, sunlight's that source of energy. Organisms that can capture energy from sunlight or chemicals and use that energy to produce food are called autotrophs or primary producers. Autotrophs mean they make their own food. So primary producers, that means they are the main producers of energy in any ecosystem. Before anything else can live there, you have to have these primary producers. They fix the sun's energy into a usable form that us lowly animals can use. So let's look at these autotrophs a little bit closer. The process in which autotrophs capture light energy and use it to convert carbon dioxide and water into oxygen and sugars is called photosynthesis. And we've looked at this section, I believe it was last semester. So we talked about photosynthesis and cellular respiration and all that kind of stuff a little while ago. So when you convert that carbon dioxide, water into those into oxygen and those sugars that can be used as energy, that's called photosynthesis. However, some of those extremophiles, they go through something called chemosynthesis, or sorry, the process in which autotrophs use chemical energy to produce carbohydrates. Carbohydrates is called chemosynthesis. However, there's also chemoautotrophs, things that use like sulfur dioxides to produce energy. So it's not just photosynthesis in plants and certain types of algae, but there's also chemoautotrophs. So here we've got the photoautotrophs. These are, once again, the main source of energy for life on planet Earth. Without them, there would be no life on this planet because nothing would be able to have anything to eat. Think about an ecosystem. Let's say you're on a plane. On the plane, you have to have grasses. Grasses provide necessary energy for things like these grazing animals, horses, cows, buffalo. And then things that are meat eaters or can't necessarily go and eat grass to get nutritional value out of it, like us, we can go and eat those cows or horses or buffalo if you've never had a buffalo burger. Pretty tasty. But those things had to have energy provided in the grasses that they're getting out on these plains, right? So there's a flow of energy, and it always starts with these photoautotrophs. Some examples of these would be like plants and algae. Once again, the grasses and those plains. The chemoautotrophs, which I kind of talked about earlier, these get their energy from inorganic substances such as salt. A lot of these live deep down in the ocean where there is no sunlight. And they live on these things like thermal vents, way deep down on the ocean floor. And that's kind of where I said, geothermal energy can kind of be used as an energy source for a bunch of these chemoautotrophs. Some examples are bacteria that live on those thermal vents and some deep sea worms. So these are creatures that are used to not having any oxygen. So they have to have a different way of producing energy, different way of using energy. They are not like most of the rest of the types of life on Earth. And then after the autotrophs, we have our consumers. Consumers are considered heterotrophs, meaning they are other eaters. They have to eat things, consume things in order to get energy and raw nutrients that they need to survive and continue, living. So these are organisms that don't make their own food. They can't just go out and stand out in the sun and photosynthesize and make their own sugars or do any of that. They have to go out, they have to hunt, they have to eat things, and they have to digest it. So they are things that have digestive systems for the most part. Another term for heterotroph is a consumer, because they consume other organisms in order to live. Some examples would be rabbits, deer, mushrooms, us. We are all heterotrophs. We need to go out and eat things. So rabbits, they can eat these plants, they eat the producers, and they can convert that directly into energy that they then use to run around and hop around and reproduce and do all that kind of stuff. The same thing for deer. They go out, they eat plants. They're probably a little bit more mobile than the bunny. And lastly, we would have the mushroom. Mushrooms are decomposers. They break down dead things. They land on, say, a dead tree. They excrete enzymes onto that tree to dissolve it, and then they reabsorb those nutrients raw. So basically, they keep that energy going when other things wouldn't be able to use it. Herbivores, these are the plant eaters. So an herbivore can only eat plants. You've got cows, elephants, giraffes. For the most part, these are generally going to be calmer animals. They're not going to be as aggressive. They're not built for hunting or anything like that. Their food is, generally speaking, relatively large. They're also going to be huge for the most part because they can just get free source of energy anywhere they go that has plants. They generally have like really complex inner workings. So their digestive system, like cows, have several stomachs, each used to digest and process the grasses and the plants that they eat. Mainly because plant matter, a lot of it is hard to digest. Like the fiber part that we eat, and we can't digest it, but it helps things move along. For a cow, that's a source of energy that they can tap into. We just don't have the same digestive system as them, so we can't do stuff like that. The next would be carnivores. Carnivores can only eat meat, so they're the opposite end of the spectrum. They don't go straight to the plant eaters. They have to eat other things that are other animals. Some examples for this would be lions, tigers, sharks. These are also considered like the apex predators. They are the things that only go out and try to eat other things made of heat. They hunt. And comes to us, we are this one. Omnivores. These eat both plants and animals. Bears, humans, raccoons, all of those, they are omnivores. So they'll eat anything. You can eat plants, get nutritional value out of it. You can eat meat, get nutritional value out of it. Doesn't really matter. We can eat both. Same thing for bears. They can go out, they can eat plants, and they can also hunt and eat meat. And raccoons, they just scavenge. They'll eat anything. We also have detritivores. Detritivores, they feed on the tissue or detritus of dead organisms, plant or animals. So earthworms, they are detritivores. Shrimp, they feed on the bottom of the waterways that they exist. So they'll basically feed off all the dead stuff at the bottom, and that's where they get their nutrients. Dust mites, that's like the dead skin of living organisms. That's what they eat, and they enjoy it. But these are the detritivores, and they actually serve a pretty necessary function. Like worms, they help stir up the ground, and they help break down some of those nutrients into their more basic forms so that the plants can reabsorb them and reuse them as they grow. So it's really good for gardening, growing things, to have some detritivores around. And not lastly, there's one more. Decomposers. So that's like those mushrooms that I talked about earlier. Fungi. These things absorb any dead material and break it down into simple nutrients or fertilizers. Decomposers are key for any ecosystem to be able to be sustainable, to last for a long period of time. These things are built to break down the dead stuff. That's their job, and turn it into a usable form so the plants can use it again, animals can use it again. They make that rich, dark soil that you see in, say, like potting soil. Lastly, for today, we'll see where we're at. 12 minutes. Perfect. Lastly, we have scavengers. Scavengers, these are things that consume the carcasses of animals, but does not typically kill it themselves. So vultures, crows, those things, they'll go and eat the dead stuff, but they don't want to do the hard part themselves. They don't go and do the killing themselves. So basically, they're opportunists. If they see food on the ground, they will try and go and eat it. These are generally the things where, if there's roadkill on the side of the road, you'll see vultures and crows kind of surrounding that, taking bites off of it because, well, it's a free meal for them. That's where we're going to end it today. Tomorrow we'll get into food chains and food webs. And then finally on Friday, my plan is to go over that virtual lab. I'll have it set up to where I can see it. I've got the paper that goes along with it, and we'll fill that out together a little bit. Most of it you're going to have to do on your own. But I'm going to show you guys how you can set it up and then answer some of the questions at the end. All right. Once again, guys, if you have any questions over what we've done today, over the notes, over anything, you can email me, put a comment in the YouTube video itself. But really the best way, just email me, let me know what's going on. Are you having issues with the material, anything like that. So I will see you guys if I can get here, and adios.